Nice. So today we're going to be shifting gears a little bit in class. We're going to be moving into discussions about human society in particular. So up to now, we've been talking about sort of how ecosystems work, like a little bit of the ecology around how ecosystems basically work. And from today, for the next several weeks, we're going to be talking about impacts of humans on the planet. And like, what are some of the ways that that's happening? What are some of the consequences for that? And then what are some things that we can do to try and ameliorate those consequences or make those better? So we've talked a little bit about population growth of species in general, all different kinds of species, but with humans it's kind of a special case. And so it's funny, when I was in the Peace Corps in Nepal has a very low population, and it was it's kind of a laid back, very, what's the word I'm looking for? Sort of a slow paced kind of society. It was actually quite a change moving from American society to Nepal, because things were much slower. But Nepal is just to the north of India. And so when we had time off, we'd often go to India to visit and see. India is an amazing place. But the joke was, when you went for a vacation in India, you came back and needed a vacation, because India was a different story. Things were moving really fast, lots of people. And so, when you're in a city like Calcutta, it's just amazing how many people you have in a small location. So you imagine what the world looked like without so many people, and then what it looks like now with so many people. And it's an interesting dynamic. So if you remember, we defined little r, which is the per capita growth rate. And that's the way that we can define how our population is growing. And so, like a lot of issues in the environment, the story about population growth depends on where you are on the planet. And so this is a map looking at rates of population growth, and I think it's 2011, so almost a decade ago. But so we have areas on the planet where growth is less than 0%. In other words, negative, right? The human population is actually declining. Some places like Northern Europe, Portugal, I don't know. But then we also have places where the population is growing pretty rapidly. So some areas in West Africa, we have populations growing by more than 3%. So it really depends on where you look on the planet when you ask the question, what's the population doing? And so globally, our world population growth rate is about 1.16%. That's how much it increases by each year. So if we were to calculate little r would be 0.0116 is essentially what that means. Now, let me show you in real time what this looks like. So the answer to the question, how many people are in the world, depends on whether we ask that question at 9 o'clock this morning, or 10 o'clock this morning, or 11 o'clock this morning. So this is our world population. 7,812,251,955, 58, 960, 64. It's going up, right? But we're on our way towards 8 billion people on the planet. And so globally, there are almost 180,000 births today on the planet. About 75,000 deaths today. Now, these are estimates, of course. There's not somebody with a counter in the hospital room like, click, every time a baby's born. These are estimates, right? But we're on our way towards 8 billion people. more people than we've ever had before on the planet. And if we look at what the population has done through history, again, the earliest fossils that we would look at and say these are definitely human, sometime between 100 and 200,000 years ago, right? But up until about 10,000 years ago, the human population was pretty minuscule. There was an important societal change, technological development that happened at this time that we'll talk about soon. But from 10,000 years ago up to almost the 20th century, the human population was pretty low, right? It was at less than 1 billion people. But then, when we hit the year 1900, all of a sudden, we started increasing. Anybody know what this little bump in the human population before 1500 was? Yeah, that was the Black Plague, right? So that was a global pandemic that decreased populations across the globe pretty dramatically. But if we were to just look at what the population has done since 1900, what kind of graph does that look like? Looks a lot like an exponential graph. Now, what has to be the case for a population to undergo exponential growth? Yeah, resources are not limiting, right? That population has to be able to increase without limitation. Now, of course, we look at technology and other things in 1900 and how they've developed, and around the world how our population grew. And technology has really increased our access to resources that we didn't have before. So we have the potential for the population to grow like it never did before. And so through the 20th century, right, this exponential growth. But you just look at this, right? Just look at this growth of the population, right? Going from less than 1 billion to, now we're up here. Now we're about up here. Right? Going to from less than 1 billion to almost 8 billion in 250 years. Or most dramatically, right, at the beginning of the 20th century, there were less than 2 billion people on the planet. But in that 1 century, the global human population tripled. So you look at the amount of folks on the planet, and it would probably be naturally assumed that there's been some consequences to the planet, right, with these massively increasing populations. But if you look up here, just right up here, what do you notice? Starting to decline, isn't it? It's starting to decline, right? That population growth rate is starting to decline. Now, humans are the only species on the planet that voluntarily limits their population growth, right? So, you know, we wouldn't necessarily say that this is all because of limited access to resources, but when we look at where things like infant mortality are highest, it does become clear that some parts of the world are a lot safer to live in than others from a resource availability standpoint, and we'll talk about that throughout the semester. All right, so if we're thinking of the environmental impact of this many people on the planet, certainly we, you know, actually let me back up a little bit. So we have all these different places in the world, and we're interested to know how society impacts the environment in each of those places. And so one thing we'll need to know about is the population in that area. But is population the only thing that's going to affect the environmental impact? What are some other things that are going to affect the environmental impact of that society? Any thoughts? Okay. Yeah, so pollution, and if we think of some of those societies that pollute more than others, what might be some things that cause one society to pollute more than others? So economy, yeah, and economy is tied to a type of advance. Well, we can leave it at that for now. But yes, right on. So economy, pollution, those things are going to vary. What else? Economy kind of captures several different things in it. Sure. Yeah, absolutely. Y'all have probably heard of or maybe you haven't, the plastic, the garbage patch in the South Pacific Ocean, where there's this gyre where all this plastic accumulates. Most of that comes from Asia and Africa, not because they use the most plastic, but just because the infrastructure is poorly developed as far as storing that plastic. So there's a model that we use to talk about the environmental impact of a society. It's called the IPAT model. And what it says is that if we're going to understand the environmental impact of a society, we need to know the population size, so like how many people are there. But we're also going to need to know a couple other things. So the environmental impact equals the population times the affluence. So as y'all could probably tell me, right, the more affluent a population is, the greater impact it's going to have on the environment, because it's going to be consuming more resources, producing more waste, right? Now, T stands for technology, and technology is a really interesting one. How do you think a more technologically advanced society's environmental impact differs from a less technologically advanced society?
Probably more air pollution in a technologically advanced society, or air pollution produced, at least.
Okay. So thinking of where the air pollution comes from, yeah, whether it's a coal-burning power plant or a car or whatever else, it's going to be more of that going on in the society that's more technologically advanced. So that's the interesting point, right? That like there's technology that can reduce our environmental impact, but up to now, what we've seen is that societies that are more technologically advanced essentially use the technology to be able to acquire resources more rapidly, right? So you think of like how we get our resources, right? Like we get our electricity from burning natural gas at the Duke Energy power plant. So the technology required to do that is pretty intense. We've got to get the natural gas from deep underground, probably somewhere up in Pennsylvania or West Virginia. We've got to transport that natural gas. We don't have a pipeline all complete. We need to transport that natural gas to the factory under pressure, right? Then we've got to transmit it to that factory. Then we've got to burn that natural gas, boil water, create steam, turn a turbine, which creates a current of electrons, like pretty intense technology, right? And so that technology has allowed us to get at that natural gas. Well, as you might imagine, when we extract natural gas that's a mile underground, the procedure in doing that, in the process of doing that, does have environmental impacts. We'll talk about that later, right? So in general, up to now, what we've seen is that societies that are more advanced technologically have, for the most part, used that technology to extract resources in different ways and more efficiently. Now, that's not to say that there aren't technologies out there that can reduce our environmental impact. So things like solar energy, wind energy, different ways like that. But up to now, when we look across the globe, what we see is that societies that are more advanced technologically have a greater environmental impact. And then the final thing that's important to think about is how sensitive the environment is. So remember that map we looked at, which looked at like net primary productivity all around the planet? There's some parts of the planet that are more sensitive than others. And so if we're thinking about growing food, for instance, some parts of the world, it's very easy to grow food because the soil is naturally very rich. Other places, we have to put a lot of fertilizer on the land, got to put a lot of water on the land, those kinds of things. And when we do that, it's going to have an impact, right? It's going to run off. So I bring this up because sometimes people will say things like, well, you know, we don't have a population problem in the US because our population, relatively speaking, is fairly low compared to other parts of the world. Our population density, right? But if we're trying to get at it from a resource perspective, right? Like if we're saying, well, those other parts of the world, like they need to stop growing their populations because they're going to use all the resources and run out of resources. The fact is that when you look at environmental impacts, it's not just how many people you have, it's how they live. And there's a statistic you might have heard that if everyone across the globe lived the same way that people in the United States do, we'd need about 4.5 Earths to produce enough resources to sustain everybody, which clearly we can't do, right? We've only got 1 Earth. So I just bring this up to make the point that we have enough resources on the planet to feed everyone and provide energy for everyone and all these things. But the problem is there's not equity as far as the means to acquire the food and the resources. And so the rate of environmental impact per person in affluent, technologically advanced societies is much higher than other parts of the world. And so it's because of this that we run into tension, right? It's because of this that there's battle over the political situation in the Middle East, because we need crude oil, right? It's the reason that we have these tensions in different parts of the globe. Y'all will have a chance to take courses in our humanities program and learn about this history of traveling around the world for resource extraction, right? There's a tension there when societies start to use lots and lots and lots of resources. And we'll, you know, these are themes we'll touch on through the course. Apologies, I talked a long time on this slide. So if we look around the world and we look at societies that use sort of like more of the production and where they live versus less, we can look at areas that are what we call ecological reserve, where they are using less than the available resources, and areas that are using more than the available resources. And so, so countries in red are countries that are in what we would call an ecological deficit. That means they're using more resources than their country produces itself. So of course, when you use more resources than your country produces, how do you fill that gap? You got to bring them in, right? You got to bring them in from other places, right? And so that's so this is the challenge. This is why our world globally is connected, and it's going to be so for the rest of all the time, right? Because people are getting things from different places. So if we look at where population density is highest globally, we see some interesting trends. So the lightest color here is where nobody lives. It's like Greenland. I don't know. I feel like Greenland and Iceland should switch names because I think Greenland has more ice because there are more people in Iceland. But when you look around the globe, where are the highest density of people? It's like a geography quiz. Yeah, so Eastern China, really high population densities. Where? Yeah, India. India is an interesting place. Lots and lots of villages. So a lot of areas with pretty high density, and then a few, it's just like Bangladesh here. And then just a few areas with like super high density. Is that Ghana? Any African geographers? I should know, but I'm not sure. Yeah, absolutely. And so, and yeah, then here along the Nile River, you can see here in Egypt, really high population density. Now, I don't know if you can see, but there are just a couple spots of cities in the eastern United States that are super high. So if we live in like high density communities, is that a good thing or a bad thing for the environment? What do y'all think? If people concentrate in the areas of high density? Bad? Yeah, why?
Air pollution, too much concrete for road runoff, there's really deforestation, urbanization. I think in India, monkeys actually live like in the cities. I might be wrong, but like people actually eat them.
You're right, they do. Yeah, when we were living in India, so there was this place in the hills, this village which was near where we were living, and like one of the things we would do, like on Sunday afternoon, they would have these Hindi movies. You guys ever heard of Bollywood? These Bollywood movies? Yeah. So they'd show those movies on Sunday afternoons. So often what people would do is like they'd cook dinner, put it in, and go watch the movie, then eat dinner after the movie. And so one time, some friends of ours did that. But in a lot of the villages there, you have like a kitchen that's kind of like detached from the rest of the house. They did that, but they didn't close the door. When they came in there, when the movie was over, monkeys all in there eating all their food. Just, it's bad. Unless you're a monkey, in which case it was good. But and they didn't know how to use the spoons. They held them the wrong way. They like all this. No, they weren't even using spoons. So yeah, so when we live in like real high concentrations of people, we'll have like local environmental problems. But when you concentrate people into small localities, what might be the benefit to that from an environmental perspective? So there's definitely a downside of like localized pollution, localized environmental impacts. What might be some of the benefits of kind of concentrating where we live into these a few certain localities?
If humans are less in an area, it's less likely that they'll be able to like go out to more areas.
Yeah, so it's a trade-off, right? So there's more untouched area if we live in high concentration pockets of people. Also, when you think of like the money it costs to build infrastructure, so like, you know, water treatment plants, sewage treatment plants, waste, landfills, those kinds of things, sometimes it becomes advantageous from a cost perspective to build all that infrastructure when you have lots of people. So there's pros and cons both ways. But as our population continues to grow, there are some folks advocating for sustainable housing, things in cities, where we can sort of lessen the impact on large parts of the land. So it kind of goes both ways. Because if you have a city, you have to bring resources in, and you got to export waste. So you got to deal with that. But the localized impact is a little bit lower. So, you know, it's just something to think about. Like, you know, some of these real high density areas that concentrate people. Interesting thing to think about. All right. So we looked a little bit earlier at human population growth through time. And the first thing I'll say about this graph is it's in log scale. So like each tick mark on the graph is 10 times, in this case, 10 times less than the one before it. So it's kind of weird to wrap your head around. But, so if we go back long time before the present, again, the earliest human fossils are like in here somewhere. But if we think of societies that of other closely related species beforehand, what's really interesting is that our population growth looks kind of like this. So tool making, evidence of that going back about 1 million years. What does it look like happened to our population up until about 10,000 years ago? What does that curve remind you of from our population biology days? What do you think? Maybe there's a line right here that it's approaching. Ding, 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 carrying capacity, yes. So, yeah, so our global population was, you know, somewhere between 1 million and 10 million, and it was stable there for a long time. Now again, what determines the carrying capacity of populations? Competition and resources, right? So we had tools which we used to get resources, and maybe we used them to compete with each other, I don't know. But our carrying capacity, if you think of our global human carrying capacity, looked like it was pretty low. Then 10,000 years ago, something crazy happened. We started, well, we didn't. Our ancestors started practicing agriculture. And the crazy thing about this, one of the crazy things to me, is that it happened at the same time in all these societies all over the globe. And as far as we know, the societies weren't connected to each other. It wasn't like someone started gardening and is like, and on social media is like, OMG, plants coming up. And they did a TikTok video and they're like picking their plants and stuff. Like there wasn't that. Like social media was not a thing 10,000 years ago. It was not. But somehow the message got across the globe. And so now when agriculture started, you don't have to move to have different crops at different years, right? You can grow your own food, stay in one place. You can store the food if you grow lots of it. And as a result, our global population increased to about 1 billion. Again, no other species does this. We essentially like bumped up the carrying capacity of the planet by changing our ability to get at resources, right? Okay, and then as we mentioned, global population fairly stable there until recently where we saw that big spike again, right? And of course, that was due to industrialization. And you just think of all the resources we use now and how that's been acquired industrially. In fact, we'll talk later in the semester, there's this thing called industrial agriculture. Like it's a way that we grow lots and lots of food. It has its downsides, it's fossil fuel heavy, it has lots of environmental impacts, but it's a way to grow a lot more food than we were able to before. So I don't know, this graph kind of sort of blows my mind. Like no other species does this, right? We're the only species that has been able to increase the resources that are accessible to us through these technological advances. And we'll talk about this later, but I've been saying that a lot lately, sorry. But the question has to be asked though, at what point is our resource acquisition today decreasing our ability to access resources in the future? That's the whole idea about renewable resources, and we'll touch on that later. Because up through agriculture, we were relying on what the earth could produce every year, right? It's whatever grows that year. But now we're doing things like taking coal and oil, which the earth produced hundreds of millions of years ago, and using it. And so we're sort of using stuff that's been produced over a long time. How long will it take to produce? Okay. So what's interesting, though, is that despite access to all these resources, our population growth rate globally has been declining, as I showed earlier. And globally, we're expected to hit 0 population growth at the end of this century. And there are a couple things at different times in this course where it's like, when you leave this course, I really want you to take this information with you. And this is one of them, because folks often say, globally, population growth is increasing exponentially, and it's just going to keep doing it until, something happens. But no, in fact, our global population growth rate has been declining, and toward the end of this century, we're expected to hit that point where folks, for the first time in the history of our species, our population is not growing. It's leveled off. Now the big question is, what number will be at when that happens, right? Like how many billion will be on the planet when that happens? And so this projection is saying we'll be maybe at 11 billion or so, because even though our population growth rate is declining, of course, before it gets to 0, it's still going up, right? So anyway, we're going to be hitting 0 population growth fairly soon. So you might wonder how people are able to estimate that, right? Like how can they say, this is when we'll hit 0 population growth? So they use something called age structure diagrams. And the way this works is you look at the population. It can be for a country, for the world, whatever. And you look at the number of individuals in 3 different categories of that population. We're not going to worry for now about the difference between male and female. There's some nuances there. But you look at the number of the proportion of the population in the pre-reproductive age group before they're having kids, in the reproductive age group, and then in the post-reproductive. And so you can look at the number of people in each of those categories, and you can predict what's going to happen to that population in the near future. What is it about the shape of this age structure diagram? And I should mention, right? So our x-axis here is like number of people from like 0 to, whatever the maximum number is, okay? So what is it about the shape of this age structure diagram that tells us that that is an expanding population? Say that again? A pyramid, Meaning that we have more people as we move down, and so then what that means is that we have more people in the pre-reproductive category than we do in this reproductive category. So we would expect in the future, as these folks enter their reproductive years, that we'll have more people having kids. And so we'd expect the population to keep rising, exactly. Does that make sense? The other extreme then, a declining population, right, is where there are relatively fewer people in the pre-reproductive than in the reproductive, and so we expect fewer people to be having kids than currently are. And this is assuming that things like decisions about family size, all kinds of things like stay the same, right? But if that all stays the same, this is kind of what you would expect. And so then a stable population is kind of in the middle. There's going to be some mortality, right? Some folks dying, of course, as they go up in age. So we might have a little bit more people in the group before, but some proportion of those will die as it gets up to here. So we can use these age structure diagrams to look around the globe and predict basically population growth, increases or decreases, right? Okay, just to give you a couple real-life examples. So these are data from Nigeria, and this is broken out in a little finer scale. So they're broken out into 5-year age categories here. And again, it's that pyramid, right? Each age group below has more people in it than the age group above it. And so we would expect the number of people having kids, again, if decisions about family size and that kind of thing stay the same, to increase. On the other extreme, this is Germany, where there are fewer people in these younger age groups, and so likely declining population size. This is the US, which has been experiencing slow growth, so it looks something like that. So yeah, so these are tools that we can use to estimate population growth rates. Okay, so we talked about the role that industrialization has played in our resource acquisition, right? And so as a result, in our population growth. So what we generally find as societies industrialize is that they go through something called the demographic transition. And this has happened in several places. The this is not a sociology class, so there are definitely subtle nuances here that could play big roles. But, sort of like societal expectations and different sorts of things. But these are things that have happened in areas in Asia, Europe, North America, South America as well. So we're going to look at, this is a figure out of your book. So we're going to look at the birth rate in red, death rate in blue, and then down here is the relative population size. All right. So in what we might call a pre-industrial stage, like that's basically been like all of history up until industrialization. Population size is pretty low, right? We've got fluctuation in birth rate, fluctuation in death rate, but population pretty low, increasing ever so slightly. Okay, then as industrialization starts to happen, this is what we see. What's the first thing that happens during that transitional stage? Yeah, so this blue line, our death rate, that drops. Why might that death rate drop as society starts to industrialize? Any thoughts? What's that? So yeah, we generally start to see improvements in medical care. So for instance, the infant mortality rate generally drops quite a bit. So yeah, I mean, so medical technology, right? Access to medical technology, those sorts of things, improved sanitation, lead to a declining death rate. Has our birth rate changed much initially? A couple shaking heads. Yeah, not a whole lot. But remembering our population growth thing, as long as our birth rate stays the same and our death rate drops, we're going to start to grow that population. All right, and then the next thing that happens is our birth rate starts to decline. Why might that birth rate decline? Any thoughts? So what have most of the people been doing in society, in that pre-industrial society? Yeah, so that's so there's a couple of reasons. One of them is that women are getting involved in the workforce a little more, and so there's a conscious decision to have fewer kids. Also, in here, everybody's been involved in agriculture, right? And there are some benefits to having large families with agriculture. Also, if you think that there were initially fairly high rates of infant mortality, a family would need to have a few kids, right? Because of the risk that they might not all survive through their younger years. So all those things lead eventually to that birth rate declining. The death rate stays the same, pretty low, and so the population increase will start to level off just a little bit. So this continues once it's in the industrial society, then the birth rate kind of keeps on going down, until eventually the population will stop growing. And so that's what we see in a lot of Northern Europe and places like Japan. We see an end to population growth, and like we mentioned with Germany, even negative population growth in some places. Because that then is the post-industrial stage where birth rate gets extremely low in some cases, and then we start to see this decline. So the decrease in the death rate generally stays pretty constant through there, but then the birth rate, due to several different factors, declines. And then over time, we actually do see a declining population. And it's really interesting to look at, for instance, like social policies in places like Germany, where there's like everyone has access to both paternal leave as well as maternal leave from work. Lots of policies actually to kind of increase, people's desire to have kids and make it easier for them to have kids, because what we find in countries in this position often is that those population sizes start to decline. And then that can lead to other societal issues. Y'all can study sociology and learn more about that and then teach me about it. You can come back and be like, hey, Dr. Gillette, yeah, I learned this interesting thing in sociology. I'll be like, hey, all right, cool. We don't have to worry about that COVID thing anymore. Yeah, let's go have a cup of coffee and talk about it. You're like, all right, sure, great. Sounds great to talk to each other, not wearing masks. I'm like, yeah, it does. So what'd you learn in your class? They'll tell me interesting stuff. That'll be fun. So anyway, that's down the road. Any questions about this? All right, so this has occurred in a lot of places. It may not be universal everywhere, but it's been the case in lots of countries across the world. All right, so economics and population growth. I'm sorry, go ahead.
So why is the size of the population, why is it fluctuating?
Yeah, so that's actually a good question. I mean, and to tell you the truth, I'm not exactly sure that I know how to answer that. I mean, yeah, so it's fluctuation in birth rate, and I'm actually not sure about that. I need to look that up and get back to you. I'm not sure. Anybody have any guesses? Oh, yeah. They could be, but then why would they only have error here, Like, I think maybe there'd be more error like all through here. But, I mean, it could be. Maybe it's harder to estimate it here. I don't know. Anybody have any other ideas? What? Could be a pandemic, These things happen. Any other ideas? I don't know. Now I'm curious. I mean, it's interesting. It's fluctuating birth rates. Like, I don't know. Maybe they just think that maybe when place to try to encourage people to have kids and it comes up, and then maybe there's not, I don't know. I'll have to check though. It's a really interesting question. I say that a lot when I don't know things. That's a very interesting question. I have to figure that out. Cool. So this connection between poverty and population growth is a real interesting one. Now, this word developed is very loaded, and we're painting with a very broad brush here when we use economics and things like per capita income to say that a country is more developed than another, because some of the experiences I had in Nepal showed me that the wealthiest people aren't the happiest people, and there are real important lessons there for sure. And this is a great time for us all to think about the times in our life when we were happiest and what made us happy. And if we think of ideally, governments and societies should promote happiness, right, in general. But, if we're looking at sort of, breaking things down on a gross domestic product kind of thing, we can look at countries that have achieved high levels of gross. Are you familiar with GDP? It's the sum total of all the goods and services that a country produces in a year, and it can be used to sort of rank them based on economic power. So anyway, when you do that, what you find is that countries that are not as economically developed are those with the most rapidly growing populations. And I think a lot of this just has to do with what we just looked at, right, with that demographic transition, that these post-industrial societies are not growing in population much. But it's really interesting because when we talked about all of the species, we said your population grows up to whatever it can be based on resources. So it's kind of funky to step back and look at this and be like, people that have access to the most resources in our species aren't necessarily having the most kids. It's just an interesting thing to think about. And one more example of how like our species is different from all others. Yeah.
So we have access to like contraception.
Yeah. Absolutely. Absolutely. Yeah. So I know. So I just kind of wanted to point out like the limits in like using this sort of thing to talk about humans, because like, yeah, we have all sorts of things that make it a very different landscape. But this is problematic, right? Because when you're adding more and more people in countries that don't have as many resources, right, there's the potential for some pretty bad conditions to occur. So when we think about resource use, let's remember then that the economic impact or the environmental impact is not just the number of people. It's all these other things too, right? Oh, you guys, this is so embarrassing. I just forgot. Can somebody remind me, what do these letters stand for?
Environmental impact, population, volume, technology, and sustainability of the environment.
Thank you, Jay. Thank you. Thank you so much. Yes. So population size, affluence, technology, sensitivity to the environment. So when we're looking at this, we don't want to say, oh my gosh, these countries are going to be using up all the resources and it's going to be this massive global problem, when these countries here are going to be higher in these two for sure, right? And so environmental impacts are going to be coming from there as well. So I mentioned this idea of an ecological footprint. How many of y'all have heard of an ecological footprint before? Some of folks, yeah. Someone care to share? What do they understand from the ecological footprint? Thoughts on that? Yeah, it's the resources that you use. Yeah, and then you can translate that to like what area of the earth is needed to like support you, essentially. So when we look across the globe, the 1980s are when we passed a global ecological footprint of one planet. That is, we need more than all the resources that our planet produces in 1 year to support our society. How is that possible? Are people like sneaking in resources from like Mars or something? What's going on here? How are we able to, how is it that the amount of resources we use is more than the amount that our Earth produces in a year? Mm-hmm. So solar power is a good example of, so what was that? Yeah. So that's an interesting, so solar power is a good example of a resource that we could really measure, like how much can the Earth produce per year? Like we could look at the solar radiation on the globe and say, this is how much can be produced per year. And so even with that, like we're essentially producing more than that. Like think of how much sun hits the Earth in a year. We're using more than that in a year, which is really interesting. Mm-hmm. Right, so that's the idea, that we're going back to these resources, that were produced by the Earth years and years ago. And so, fossil fuels were produced hundreds of millions of years ago, so we're using those today. So the idea is, think of it this way. I know y'all are trust fund kids and you have millions of dollars in the bank, right? So as long as you live off the interest, the amount of money in the bank is never going to decline, right? Whatever the interest is that's produced every year, if you just live off of that, you're good. The amount's not going to go down. And you can think of this as the interest, right? This is the amount, this is the energy the Earth produces every year, right? The amount of energy the Earth produces every year is like the interest on that account. As long as we just live off of that, then we're never going to affect the Earth's ability to produce those resources. Okay, but let's say that you just need that second Mercedes-Benz. And so you go and you spend a little bit extra. You're spending more than the interest that's produced on that account every year. Now the principal drops a little bit, right? And so when that principal drops, then the amount that it gives you in interest every year drops too. Now we're assuming interest rates stay the same, which they don't, but anyway. So the same thing is with Earth, right? When we start using more resources than it produces every year, we're essentially kind of chipping into the principal. We're not just using what it produces every year. And so that process of using more resources than it produces every year has some environmental impacts that reduces the Earth's ability to produce those resources. So basically, once we went up above 1 here, globally, we kind of started dipping into the principle, if you will, of resources on Earth.